Hi everyone. I found an interesting comment on a GitLab track ticket tonight, and wanted to share some thoughts about it. So today we're going to talk a little bit about impredicative types and type families, and how type families just can't really work with impredicative types. But I don't. Well, maybe this will be a problem. I don't know if this will be a problem or not. Anyway, it all starts from this comment down here. So this is for those of you who want to follow at home. This is ticket 11715 here, and this is a long-running ticket about how GHC is confused about constraint versus type. So I'll explain that. Actually, maybe we'll start with that. Here we have, let me open up my little file that I use to play around in. Lots of extensions enabled. But I don't need that right now. And I don't need that right now either. Okay. So here, so the first question is constraint versus type. So constraint is the kind of constraints, right? So if I just load this file into GHCI, so first off, we can see this is hot off the presses here. This is head from just a few days ago, and it's in particular, it's after impredicative types has been implemented, using quick look impredicativity. So maybe we'll explore that another day. But it allows us to use polytypes, types with for all in them, sort of in lots of places that we couldn't before. So very exciting stuff. But here I want to talk about constraint versus type. So the way we can understand this, if I ask what is the kind of eq int, that's a constraint, right? That's something that can go to the left of a fat arrow. As opposed to what is the kind of maybe int, well, that's a type. So here type is being rendered with this asterisk, but it's the same thing as type. We can also write it with star sometimes. And it turns out internally, GHC treats both constraint and star the same. And this is really useful because when, let's say if we look at the show function. So show here is actually a function of multiple arguments. First, it takes a show dictionary. So this is the runtime piece of information that tells us how to actually render A's into strings. And then we have something of type A. And so here in Haskell, we print this out with a fat arrow and a thin arrow, and they look different. But internally in GHC, it actually considers these two different kinds of arrows the same. And that means that the kind of this and the kind of this have to be the same. If you want to look at more gory details, you can look at the ticket. This is something actually that's quite uncomfortable. The fact that constraint and type are different in Haskell, but they're the same in core. It's a bit weird, and it causes some frictions in a few places, and that's what that ticket is about. But what particularly intrigued me is now we can do this nonsense. So let me write out the nonsense, and we'll see what it really looks like here. So if I write type family FA, where F A arrow B equals A arrow B. So now I have that type family, and if I ask GHCI to evaluate, that's kind exclamation point, not only get the kind, but actually evaluate the type. If I ask it to say, what is fint? Well, we don't know what fint is. It's just fint. But if I ask it to say, what is f of bool arrow car? Notice there's no f here anymore. So we've reduced f. We've sort of run this type function. Okay, so that's pretty cool. Excuse that. There was a small mistake there. Let's just pretend that didn't happen. So if I'm looking at, if I want to reduce f eq int arrow car, oh, perhaps I intended to use impredicative types. Okay, let's turn on impredicative types and try again. Oh, that's painful. First off, it reduces. The f disappeared. But then, look, now the fat arrow has become a thin arrow. So this is just utterly bogus, right? And so I was looking at that and saying, okay, that's really terrible that can happen. But it got me thinking that other terrible things can happen if we try to mix impredicativity with type families. And the reason is that type families are really only designed to work with simple monotypes. None of this fancy fat arrows or for all types or anything like that. So let's explore another scenario here where we can run into trouble. So I'm going to get rid of this type family f, and instead I'm going to have an innocent-looking type family id, where that's really just the identity function. But now I'm going to write a function f here that takes an id for all a arrow a, and returns a car. And so fx x applied to z here, that should work, right? Because id of for all a arrow a, that should just be for all a arrow a, and then I can apply that function to a character. I should get a character back because the function, this x function is going to return whatever type it's given. This kind of looks like it should work. When I try to compile it, I need to enable impredicative types. So let's enable impredicative types. And then we get this strange error. So what's going on here is that we see when GHC sees that x has this type here, it doesn't immediately try to reduce that type. It doesn't immediately say, oh, id a, that's just a. So it keeps this as this type here. And then when we see that x is applied to some argument, what we have here is we know that x has type id of all of this stuff. But then what we need to know is that this is actually equal to the type car arrow car. So we know it has to be car arrow car because the argument has type car, and we know that the result of our function f has type car. So GHC is clever enough to know that means that x here must have type car arrow car. But it's saying that these two types must be equal. Then later it says, oh, id, I know how to reduce id. And so it simplifies this into, for all a arrow a equals car arrow car. And these two types are different. We can't do that in GHC, and that's exactly why we get this error. So normally, if I didn't have the id in the way, right, this is going to work now. Oh, well, if I don't do silly things. This works now because when it sees x here, it knows x is polytype, and it knows not to say that equals car arrow car, but that we should instantiate it to car arrow car. So it's going to instantiate the a to become car, and all will be well. The problem is that the id, when I put the id back here, that gets in the way. And so this is just one small example, but really type functions, we sort of need to know where the polytypes are ahead of time. And that's why impredicative types is so hard. And type functions sort of allow us to skirt all of this. And so in thinking about this all, just before recording this, I filed this ticket. I guess this is 18762, explaining this scenario and that we have some work to do to sort this out. Anyway, I thought this was interesting. I hope you did too. And thanks for watching. Bye.